This is the Sudarshan, myself. I'm from second BTech first semester as during the year 25-26 in studied in Srinivasa Ramanujan Institute of Technology. My uploaded in CA2 topic is time and frequency domain relationship in system response. Subject name is signals and systems and stochastic process. Subject code is 23A04301. Myself Sudarshan. My ID is 24443. My department is EC. The topic is time and frequency domain relationship in system response. Introduction to time and frequency domains. The system response can be analyzed in both the time and frequency domains. Understanding the relation between these domains helps in designing and analyzing system effectively. This presentation explores how signals and systems behave across these two domains, time domain and frequency domain. See in these pictures. Time domain response. The time domain response describes how a system reacts over time to given input, provide information about transient and steady state behaviors of the system. Visualization of signals in the time domain helps in understanding the system's dynamic performance. See in the graph. Frequency domain response. The frequency domain response shows how a system responds to different frequency components of an input signal. It characterized by the system transfer function, which includes magnitude and phase. Analyzing the frequency response helps in understanding system stability and filtering characteristics. Fourier transform and its significance. The Fourier transform converts signals between time and frequency domain. It decomposes a time domain signal into a constituent sinusoidal frequencies. The mathematical tool is fundamental for analyzing and designing system in the frequency domain. Time domain of and Fourier transform is equal to frequency domain SW. Difference between impulse response and frequency response. The impulse response in time domain fully characterized by linear time variant through LTI system. The Fourier transform of the impulse response yields the system frequency response. The system relationship allows engineers to analyze system behavior in the frequency domain using time domain data. See in the relation between frequency response and impulse response we have derived y of n is equal to sigma and m is equal to minus infinity to infinity h of m into x in n minus m. Let x of n is e power I omega n, so y of n is equal to m is equal to minus omega 2 omega h of m e power I omega into n minus m e power I omega h sigma m is equal to minus infinity to infinity h of m e power minus I omega m. The transfer function. The transfer function is the ratio of the Laplace or Fourier transform of the output and to input in the frequency domain. It provides a comprehensive description of the system dynamics and sustainability. The transfer function directly related to system time response to its frequency response. Transfer function. The transfer function ratio Laplace transform output the Laplace transform input when all our initial conditions are assumed to be 0. System h of t input is x of t, output is y of t. Y of t is equal to x of t into h of t. Y of s is equal to x of s into h of s. H of s is equal to y by s, y of s by x of s. Initial conditions. This. Bed plots and their use. Board plots graphically represent the system magnitude and phase response. Over a range of frequencies, they are useful for analyzing system sustainability and designing controllers. Bed plots bridge the understanding between the frequency response and system response in the domain. Inverse Fourier transform and signal reconstruction. The inverse Fourier transform reconstructs a time domain signal from its frequency component. The process demonstrates the duality and comparability the two domains and complementary the two domains. Its essential filter design and signal processing applications. Practical applications and examples. Engineers use time frequency domain analysis and signal processing. Examples including filtering noise, designing controls, and analyzing system stability. Understanding the relationship between domains and enhances system optimization and troubleshooting. Application signal processing, image processing, heat distribution, wave application, light amplification, radio. Summary of key concepts. The time and frequency domain free different but interconnected perspective of system behavior. Fourier analysis server as the bridge between the two domains. Mastery of their relationship crucial for effective system analysis and references. Ogata K. 2010 Modern Control Engineering Precision. SFH 99 Signal and System Fractal Digital Signal Processing Principal Algorithms and Applications. Thank you.